Now, we are exploring one of the most exciting frontiers in artificial intelligence. By the end of this video, you will have a solid understanding of what diffusion models are, how they work, and their groundbreaking potential. First, let's define what diffusion models are. At their core, diffusion models are a class of generative models. This means they can generate new data that resembles the data they were trained on. Imagine being able to create new images, music, or even text that looks and feels like it was made by a human. That's the power of generative models, and diffusion models are the latest and greatest in this field. The term diffusion comes from the process these models use to generate data. They start with pure noise and gradually transform into meaningful data through a series of steps. Think of it like sculpting a statue from a block of marble. Initially, it's just a rough shape, but with each polish, it starts to resemble the final masterpiece. Here's a simplified breakdown of the process. The model begins with a sample of random noise. It then goes through a sequence of steps, with each step slightly refining the sample, making it more structured and meaningful. Mathematically, this involves reversing a diffusion process, which in statistical terms means reducing uncertainty and adding more structure at each step. To understand this better, imagine each step as a small improvement on the last. Initially, the model adds a bit of structure to the noise. In the next step, it builds on that structure, and so on, until we end up with a coherent piece of data. The beauty of diffusion model lies in this iterative refinement. Now, let's see these models in action. One of the most impressive applications of diffusion models is image generation. By starting with a noisy image and refining it step by step, these models can create incredibly realistic images from scratch. But it doesn't stop there. They can also generate music, synthesize voices, and even create coherent pieces of text. The implications of diffusion models are vast. In the creative industry, they can be used to generate new artwork, compose music, and write stories. In scientific research, they can help simulate complex systems, model molecular structures, and predict outcomes. The potential is virtually limitless. As we look in the future, diffusion models represent a significant leap forward in AI capabilities. They open up new possibilities for innovation, creativity, and problem solving. By continuing to refine and develop these models, we can unlock new potentials and push the boundaries of what's possible with AI. Next, let's take a look closer at first diagram from this article. Here we see the forward diffusion process, where we start with a clean image. As we move forward, we add noise at each step, gradually transforming the image into pure noise. This forward process is essential because it teaches the model how data gets corrupted. In the forward diffusion process, each step adds a bit of Gaussian noise to the image. By the end, we have an image that's completely unrecognizable. This step-by-step addition of noise helps the model learn the distribution of the data, which is crucial for the next phase. Now, let's examine the reverse diffusion process. This is where the magic happens. Starting with pure noise, the model uses what it learned during the forward process to gradually remove the noise step by step until it reconstructs a clean image. In the reverse diffusion process, each step refines the noisy image a little more. The model applies what it learned to denoise the image iteratively. By the final step, we have transformed the noise back into a coherent and high-quality image. This reverse process is what allows diffusion models to generate such realistic data. So the practical implications of diffusion models are immense. Let's break down. In image generation, models can create lifelike images that can be used in entertainment, advertising, and even art. In music, they can compose original pieces that are indistinguishable for those made by human musicians. And in the end, text generation. They can write stories, articles, and even codes. For instance, consider an AI-generated image. The model starts with a random pattern of pixels and through the reverse diffusion process, it crafts a detailed and realistic picture. Similarly, in music, the model can start with a random sound and refine them into harmonious composition. And in text, it can begin with random words and phrases, gradually forming coherent and meaningful sentences. I hope this article has sparkled your curiosity and given you a deeper understanding of this exciting technology.